This is the video for section 5.4 notes, slides 18 and 19. It says, using a tangent line to f of x at x equals c, approximate values of f of x for x values close to c. All right, so this is a question that is kind of related to curve sketching. So section 4.4, all right, and we actually saw a few multiple choice questions that were similar to this back in unit 4. Okay, but so let's say that I have a curve here, and let's say that it is a decreasing function that is concave down. All right, so here's a particular point. Let's say it's c comma f of c. All right, now you know that there's a tangent line here. All right. And if we know that this curve is concave down, that means the tangent line is always above the curve. All right. Now, if we had a decreasing function, yet it was concave up, right, we would have a tangent line that was always below the curve, right? So if this is c comma f of c, right, this tangent line is always below the curve, right? And so we can say if f is concave up, meaning f double prime is greater than 0, right, then an approximation using a tangent line is an underestimate, right? So this curve is concave up here on the right. That means the tangent line would be an underestimate. Okay, if f is concave down, right, then f double prime is negative, means that the approximation is an overestimate, right? This tangent line is above, right? No matter which way we go, right? If we go to the left of c, the tangent line is above, or if we go to the left of c here, the tangent line is below. Now remember, these were for decreasing functions. What if the function is increasing? Well, if it's increasing but it's concave up, notice the tangent line is under the curve, right? So concave up, right, like this f double prime is greater than 0, that would lead to an underestimate. Increasing but concave down would mean that the tangent line is above the curve and would lead to an overestimate. All right. So what are we going to do? All right. We are going to write the equation of a tangent line. All right. So number one, we're going to write equation of a tangent line. Okay, so we know how to do that. We've been doing that for a long time, right? Write the equation of the tangent line, and then we're going to use x equals c to approximate a value of f. And so what we're going to do is we're going to evaluate the tangent line at x equals c, right? And that's going to give us our estimate, all right? So let's take a look at this picture over here. All right, let's say that I wanted to estimate or approximate f of c plus 1, right? So I'm trying to approximate the value of f of c plus 1, all right? Now I'm going to do that by finding the value on the tangent line at x equals c plus 1, right? That's kind of the idea, all right? So let's take a look at the specific example on slide 19. All right. So it says find the approximate value of y equals root x at x equals 9.2 from the tangent line to the graph at x equals 9. All right. So the first step is that we are going to write the equation of the tangent line at x equals 9. Okay. All right. So if I'm going to write the equation of the tangent line, all right, what do I need to know? So to write the equation of the tangent line, I need to know a point and a slope. So we're writing it at 9. So 9 comma, well, square root of 9. So 9 comma 3 is the point. All right, and what about the slope? All right, so slope of the tangent. Remember, we have to find the derivative. So y prime. All right, what is the derivative of the square root of x? Well, it's 1/2 x to the negative 1/2, right? So I want to evaluate y prime at x equals 9, right? So remember, we're writing the equation of the tangent line at x equals 9, okay? All right, so 1/2 9 to the negative 1/2. All right, so what does 9 to the negative 1/2 mean? Well, that really means 1 over the square root of 9, which is 3. So 1/2 times 1/3 is 1/6. So that means the equation of the tangent line is y minus 3 equals slope 1/6 times x minus 9. All right, so that's the equation of the tangent line. All right, so that's step 1. So now step 2 is to use the equation of the tangent line at x equals 9.2. So now I'm going to plug 9.2 in for x. So 1/6 times 9.2 minus 9. All right, so now y equals, all right, so I'm going to add 3 over. All right, I have 1/6 times 9.2 minus 9, that's 0.2, which is 1/5. So I have 1/6 times 1/5 plus 3. So 1/6 times 1/5, that's 1/30th. So 3 and 1/30th, right, is the value of y. So what is that? That is the approximation of the square root. So the square root of 9.2 is approximately 3 and 1/30th. That is what we are doing. Now, I know it doesn't ask it here, but would that be an underestimate or an overestimate? All right, so let's think about the value of the second derivative. Okay, so the value of the second derivative, well, if you think about it, right, what's the value of the second derivative? So y double prime equals. All right, so I would multiply by negative 1/2, so that'd be negative 1/4 x to the negative 3/2. Now, no matter what number you plug in there, right, obviously from the original domain, right, it's going to be a negative number. So y double prime is less than 0, therefore the curve is concave down, and a tangent line is going to be above the curve. So 3 and 1/30th is an overestimate of the square root of 9.2. All right. Now, if you wanted to, you could actually take out your calculator and calculate the square root of 9.2, and you would realize that 3 and 1/30th would be very, very close, yet it would be slightly larger than the actual square root of 9.2. All right, so that is linear approximation. All right, so that is slides 18 and 19. We will do slides 20 and 21 in class.